In this class, we're going to take a look at how you solve simultaneous equations. So simultaneous means things happening at the same time. So in these questions, you've got equations happening at the same time. So you've basically got two equations. So the equations basically in these questions come in pairs. And what we're trying to do, just like a normal equation, is solve for the variable. So we're solving for the x, solving for the y, but the difference is the x and the y value has got to satisfy both equations at the same time. That's why they're called simultaneous equations. They're quite important, these. If you end up doing sort of a pre-calculus course, calculus, even beyond calculus, or further into calculus, then you're going to keep using these. So this is quite a fundamental core skill to get down. So definitely spend a bit of time learning about these. One of the things to be aware of, if you've only got, say, one equation, if we had just this second equation here, 5x plus y equals 13, that equation's not solvable for a unique solution, because if you've got more variables than you've got equations, so if you've got two variables but only one equation, that means you can choose infinitely many x's and y's to make 13. So we say that there are infinitely many solutions, so it's not really solvable as a unique solution. You need as many equations as you've got variables. So if we've got two variables, an x and a y, then we need two equations to be able to have that second constraint, which then allows us to form a unique solution pair, x and y. That's what we're trying to do in these questions. The way we go about this is basically to work in columns. So if your equations are not set up in columns like this, with the x's and the y's and the numbers like stacked above each other, then rewrite them so that they are in that form. Most of these questions will be in that form initially, but if they're not in that form, then manipulate them to get them in that form, because we're going to kind of work them in these column sort of methods. Good practice as well to label your equations. I mean, it's not vital that you do this, you don't have to do this, but generally with these questions, especially as they get more difficult, we're going to be manipulating the equations and making new equations out of the original equations. So knowing which one's which, and so 1, 2, we might even end up with a 3 and a 4, being able to distinguish them becomes a bit more important. Okay, so the method we're going to use here is called actually elimination of a variable, and what we're going to try and do is get rid of either the x or the y, just to leave a normal linear equation which we can solve in the sort of normal way. What you do is you look at the coefficients of the x terms and the coefficients of the y terms, and you're looking for one which is kind of matched up. So here we've got a 4 over the x and a 2, so they're different, right? They're not matched up. Here with the y, we've got a plus 1y and we've got a minus 1y. So ignoring the plus and the minus, these are both 1s, so they are kind of matched up, I guess. It's the ones that are matched up that we're interested in. When we come to these here, we see the x's are matched up. It doesn't matter if it's the x or the y that's matched up, as long as one of your variables matches the other one. And it doesn't matter about the sign. These are both positive 5. This is a plus 1 and a minus 1. That's fine, it doesn't matter, as long as they're the same kind of numerical value. So what we do is we effectively think of this as kind of like a calculation, and we're going to either add or subtract in the columns. And the way we're going to do it, the way we're going to decide whether to add or subtract, is about getting this to come to 0. So 1 plus or minus 1 to make 0, well, that would have to be a plus, because 1 plus minus 1 basically gives you 0. And that's a decision you'll have to make. Do I add them or do I subtract them? That's the only two options, add or subtract. So plus 1y plus minus 1y would basically give you 0. And I'll write the 0 in here just for illustration, but generally we're not going to write the 0 in there. We also then add the other items in our rows, so we add everything basically. So 9 plus 3 gives us 12, 4x plus 2x gives us 6x, and just writing another line without the 0 in here, we would have 6x equals 12. So what we've been able to do there, just by adding the two equations, is to eliminate the y variable. We've now basically formed a new equation, which is a fairly trivial linear equation, and we just solve that by dividing both sides by 6 to get x equals 2. And that's basically the method for how you start these simultaneous equations. It's a little weird at first, it's a little complicated, it's a new technique, like all new techniques. If you're not used to it, then it'll take a while to kind of get used to it. But all that we've effectively done there is identified the matched up variable, and then in this case added all three columns to create this new equation. We're only halfway done though, because we've got the x value. We also need to find the corresponding y value. To do that, we're just going to substitute that x equal to 2 into either of the equations. It doesn't matter, this solution has to satisfy both. You'll get the same y value regardless of which equation you put this into. I would say try to avoid negatives and try to avoid awkward numbers. So let's maybe go for the first equation. So 4 times x, that's now going to be 4 times 2. So let's go 4 times 2 plus y equals 9. 4 times 2 is 8, so we get 8 plus y equals 9. Just moving that 8 to the other side, it would become 9 minus 8, which is 1. So that's basically our solution pair. X equals 2, y equals 1. So these numbers satisfy both equations. So for example, plug in these numbers into the second equation. 2 times 2 is 4, minus 1 times 1 is 1, 4 minus 1 is 3. So the equation is satisfied. Okay, so we'll take that as our kind of warm-up, getting used to the technique question, because it is a little fiddly at first. We'll have a look at the second one. It's a fairly similar-ish kind of scenario. The difference this time, we've got our x's matched up, but like I said earlier, it doesn't matter which one is matched up and which one isn't. We'll label our equations again. We never really needed the labels in the first question. We probably won't need them here either. In the next class, I'm going to talk about a more difficult scenario where the labels become more important, but it's maybe just good practice to get used to the labels at this point. In fact, one thing you could do with the labels, when I substituted here, I substituted into equation 1, so I could maybe write this more fully and write substitute x equal to 2 into equation 1. That's maybe one use of the labels at this level. So again, we're just going to decide whether to add or subtract to eliminate a variable. It's the x variable that's matched up here. To get that to go to 0, we would need to subtract in this case. So we're subtracting all the way through all three columns, because 5x minus 5x will give us 0. If we did a plus, 5x plus 5x would give us 10x, and that's not what we want. So that's going to eliminate to 0. 4y minus 1y is going to give us 3y. 22 minus 13 is going to give us 9. So after that first move, you've gone from this like really horrible two equation scenario to usually a fairly trivial linear equation. That's kind of the beauty of these. Just really easy to solve that one, dividing both sides by 3, and we get our first solution, y equals 3. Just going to substitute that into either of the equations. Doesn't matter again which. I'll go for equation 2 this time. So we're substituting y equals 3 into equation 2. A common mistake here is, or it's not really a mistake, well, it is a mistake. It gets you the same answer, but rather than substituting the first solution into an equation, a lot of students will rework the technique to get the other variable solution in the same way you got the first one. That's generally just going to take longer, and it's going to be more difficult and more chance of making a mistake. Just take the first solution and substitute it into one of the equations to get the second solution. So substituting this into equation 2, we get 5x plus y. Well, we now know the y value is 3, so it's plus 3 equals 13. Just solving this like a linear equation. So taking the 3 over, 13 minus 3 is 10, dividing both sides by 5, and we get x equals 2. So that's our solution pair this time. Y is 3 and x is 2. So we could take those numbers and just check that they work in the other equation. So taking equation 1, 5 times x, that's 5 times 2 is 10. 4 times y, that's 4 times 3 is 12, so plus 12. 10 plus 12 does equal 22. So we've kind of validated that the solutions are correct. So this method of solving simultaneous equations by elimination of a variable is kind of your starting point. And it's kind of the method it is a method you'll always use for these, but the equations get a little more complicated. You've got to do some prep work for the more difficult cases before you can eliminate the variable, but it is still going to be elimination of a variable. Once you've got used to this technique, which does take a little time at first if you've never seen it, then you can move on to the more difficult ones. And in the more difficult ones, we basically need to create one or two new equations by multiplying the equations to force the variables to match up. Once you've done that, then the rest of the working is going to be the same. But if this is brand new to you, just make sure that everything there makes sense, because it is a little new. It's quite an unusual technique at first. Once you're convinced that it does make sense, try a few practice questions. Once you're comfortable with those and getting the answers correct, then move on to the next type, which are just slightly more difficult.